This is an interesting question in work energy and integrated problem. This is a 2 kg box of holiday candy takes 2 seconds to slides down a frictionless chute with an angle of 40 degrees with respect to the horizontal on a table with friction coefficient of 0.6. First bit, what is the acceleration of the box on the ramp? Now the box is on the ramp and then the ramp is frictionless and the base is having a friction with a coefficient of friction 0.6. The angle it is making with the horizontal is 40 degrees. This is the angle. So we have to, this is the angle, 40 degrees angle. This is 40. Okay. Now here is the free body diagram. And then this is the FG and this is FG cos theta and this is FG sin theta because this is the angle, opposite side is sine and adjacent side is cos. So accordingly, I resolved the FG into components and then this is Fn. Now here the only force acting is Fg sin theta. That means horizontal component of the weight. So sigma Fx is equal to Fg sin 40 is equal to max. Mass is 2 kilograms. Acceleration A is equal to acceleration due to gravity. A is equal to G is equal to 10 meters per second square. I took in this in solving this problem. And then sin 40 is equal to 2ax. This gives the value of ax is equal to 6.42 meters per second square. Second bit. What is the magnitude of acceleration of the box on the flat surface? Now we have to find out at the flat surface. When it comes to the flat surface, friction is the only force contributing for the acceleration. So if no other force is acting and the friction is acting in the opposite direction to make the object to stop. Okay, so the friction is equal to ma. The frictional force is equal to, now you know friction is equal to F friction is equal to mu Fn. Mu Fn. Okay, F friction is equal to. Here, this is the object. Now you see the free body diagram. Fn is equal to Fg. Therefore, F friction is equal to mu mg. Fg is equal to mg. Therefore, F friction is equal to mu mg. Mu mg is equal to ma. Mass goes off. Acceleration is equal to mu times g. So therefore, acceleration mu is given as 0.6. Therefore, A is equal to 0.6 times 10. That is equal to 6 meters per second square. Third bit. How far will the object slide on the flat surface before coming to a stop? Now I will find out the velocity at the end of the ramp. Initially, the object is at rest. That is why VA is equal to 0. Acceleration is equal to 6.4 meters per second square. I found out here that I took. And then he gave T is equal to 2 seconds to come down the ramp. So if T is equal to 2 seconds, I use the equation Vf is equal to Va plus At. Here Va is equal to 0 and At is equal to 6.4, T is equal to 2. Therefore, Vf is equal to 12.8 meters per second. Okay. Now what I have to find? I have to find out the distance. Okay. We know work done is equal to change in kinetic energy. Therefore, W is equal to delta K. Here the work done is work done by the friction. Therefore, mu mg d. Mu mg is the frictional force. F friction is equal to mu mg. That is the frictional force, and then displacement is d. So mu mg d is equal to half m Vf square minus Vi square. Finally, the object is coming to rest, and then the velocity with which it comes down is the initial velocity. So 12.8 square minus 0 square divided by 2 into 0.6 into 10. That gives the d value 13.65 meters. So here the answer is 13.65 meters. Next, if the mass of the object was half, how would the acceleration of the object be affected? It will not affect the acceleration because here we are taking the acceleration Vf is equal to Va plus At. The kinematic equations will not involve the mass of the object. So it will not affect the acceleration of the object. If the mass of the object was doubled, how would the normal force be affected? We know Fn is equal to mg. You see, Fn is equal to fg. Fg is equal to mg. Fn is equal to mg. Suppose m is equal to 2m, then m dash is equal to 2m. I put Fn dash is equal to 2Fn. This becomes a 2m now. So Fn becomes 2m. So the normal force doubles. That is the answer for this question. Hope this helps. Thank you. Bye bye.